Today, we're diving into a major shift happening in enterprise IT. It's no longer just about using AI to write code or analyze data. It's about building and managing systems that are themselves powered by autonomous AI agents. This brings up huge questions about complexity, trust, and control. And to help us navigate this new world, we're joined by Bernd Greifeneder. Bernd is the founder and chief technology officer at Dynatrace, a company that has been thinking about AI and complexity for a long time. Welcome to Technically Speaking, where we explore how open source is shaping the future of technology. I'm your host, Chris Wright. Thank you for joining us and welcome to the show, Bernd. I thought we could start off by, recognizing that the world is really changing rapidly. When you were getting started, it was about much simpler application architectures, 2 and 3 tier apps. And today we have these massive microservices architectures, and all of that complexity gets more and more challenging to manage. And at some point we're needing to offload the management of that complexity to computers. So enter AI and AI ops and some of these kind of high-level concepts, the potential for agents. Why don't you kind of dig in from your point of view? Where are we, and what are we doing to help tame that complexity?
So that's really a very interesting challenge and question, because in the original times it was all about the ability to observe systems in order to understand what's going on. Complexity grew, virtualization came at some point, suddenly systems became ephemeral, everything is moving all the time. Systems grew from a handful of servers to thousands of servers to now we are thinking more millions of servers. This is the new dimension we are thinking about. So it is clear that originally it was making systems work. Now it becomes that you actually need AI to, on one hand, manage these systems properly, because it is beyond humans to actually keep them working and delivering. But also at the same time, you need AI to run, for instance, your production. You need also now to observe what's going on in these environments, especially the more people then not only run their standard digital services, their standard cloud native services, but cobble them together with additional AI services. Then the complexity increases even further, because especially AI with its stochastic behavior, you never know sort of what it's going to do and to what to talk, makes it even more important to also observe the AI, what the AI is doing. But because of this complexity, you need AI sort of to help you manage this. The term of AI observability means to actually observe the AI of AI-driven cloud and AI native systems, versus the classic term, legacy term actually, of AI ops means you use AI to operate your production environment. And actually by combining both of AI to run the system, but also to observe the AI that is in those systems, because you need that input of the data in order to steer it, because you can't manage what you don't measure.
I think the pithy, you can't improve what you're not measuring kind of concept just really applies in spades here. And then add to that the complexity that you're describing, the need for computer support, automation, AI agents to help humans manage this complexity I think becomes more and more obvious. Where did you shift your focus from thinking about applications?
So honestly, it was already in the age when virtualization and vMotion sort of kicked in, that it became obvious to us that the world will become more complex and more dynamic. So this is why already 10 years ago, it was clear to us that we have to deal with the real-time ability to discover what is the system, how is the system actually connected to each other, sort of on the vertical stack as well as on the horizontal one, create sort of a digital twin of the production environment, and use this as a directed graph for further the analytics to really analyze true causation, not just correlation. We also figured in order to do automatic analysis and build expertise into the product, we'd need to bring all the data together and enrich it with additional context. And as we did those prerequisites, we figured out actually, combining that together, adding then particular AI routines to it, turned it already into a causal AI engine that actually helps our customers with fully automatic root cause analysis that is based on facts. So for instance, typically when there's a problem arising, it's on one of the tiers, there's a ripple effect through all the other tiers, then suddenly, bing, you get the thousands of alerts, but you don't know exactly what was the first one. The first one that alerted might not be the cause because of cause and effect can be different. So this issue is that we have clearly solved by having a true dependency graph that understands not only the temporal kind of item, but actually the cause and effects. So in that type of knowledge of causal AI is a very actually deterministic approach, and this combines super well now with the generative AI approaches that leads to agentic. So I paint it this way: you get the best of two worlds here. Sort of you have with the large language models the artistic, sort of the creative part, and you have with the causal AI, the fact-based, the scientist kind of knowledge. And I think by combining those, this is giving us a great path towards agentic AI and delivering customers an agentic AI effort that helps them to proactively and autonomously protect from becoming issues, protect from security, help them optimize towards goals, help to automatically and autonomously remediate.
So much of the world's focused on generative. It's really taken all the oxygen out of the room, and we forget the power of predictive models. I think one of the interesting sort of requirements for building such a predictive model would be the data collection. And you're describing this complex topology graph and the relationships between components in the system. How do you approach that part?
Yeah, with almost everything, the answers you get depend on the input you provide to whatever analytics or AI you are running. So the same is true here. This is why we care foremost of the quality of data. But there are a couple of key aspects. So one is real-time learning is key because if you have to make fact-based decisions about your production system with all those ephemeral workloads that change every second or even more frequently, you can't use a model that you have trained yesterday. So this idea learning from past outages is a bit limited because no one wants to have a million outages from the past in order to predict into the future. Also, the systems, the services are changing so much in production that it's pretty hard if you use historical based training. So the key is that this aspect needs to be real time, and this is then informing sort of this real-time topological graph. So the predictive portion is then a mixture actually of leveraging that real-time detection with, depending on what predictive use case it is, using more or less of history. This is also where actually a data lake house is handy, especially one that doesn't require schemas and lengthy pre-setup of what needs to be indexed and what not, because this allows the Agentic AI at any time to come up with, okay, now I need to have an answer to how is this set of clusters doing versus this business goal, and do I need to predict here certain orchestration parameters. Agentic AI with such a schema and indexless approach to a data lake house can get that answers then on the fly and drive and react accordingly.
Yeah, I think the couple of things that come to mind are, well, there's always the garbage in, garbage out problem. So there's some potential data cleansing, or at least ensuring that you're collecting the right data. That huge sort of just wealth of information that comes from all the logging across the entire system that you can then query and understand current states. The reasoning piece I'm curious about. So you have an agent that's trying to understand the state of the system and using reasoning to really produce the best worldview of the current state of the system. Anything worth highlighting in that context?
Yeah, the key one here is that the reasoning builds on actually a whole set of different expertise. So it's not just one agent, it's a sort of, I think of a team of agents that know their world of expertise. Let's say there's the expertise of Kubernetes, there's the expertise of databases, there's the expertise of driving towards a business goal. So that this agentic setup is using that expertise in a collective fashion and using as much as possible of deterministic data and results under the hood to minimize the impact of hallucinations out of this. We want to make it as scientific as possible to get reliable outcomes. But this is also where then the ecosystem comes in, because, for instance, Red Hat knows the Red Hat systems the best, so incorporating Red Hat agentic knowledge into this entire collaborative process makes perfectly sense to drive the optimal outcome for then the customer.
There's got to be an element of trust that's really important here, because we're offloading some forms of responsibility to AI and AI agents. How do you think about trust in this context?
Yeah, that's a big one. And we all know that AI is super capable. And the problem, though, is that if the cool stuff only works 5 out of 10 times, and the rest it's hallucinating, doing something wrong, or never converging at all, it's not much of a help. So this is actually where the whole reliability is an important one. And actually, this is the much bigger challenge that we all in the market have ahead of us. This is also why I strongly believe in all of this agentic AI setup. It is imminent to have as much as possible as deterministic analytics, routines, behavior in the mix to complement the stochastic and probabilistic nature of the typical large language models that are used for these agents. Combining that in the right way to minimize hallucinations or a wrong behavior is absolutely key to build the proper trust. And this is also the reason why right now most of that happens with the developers, because they're still the developer overseeing the code, but do you still trust then the developer accepting all code changes and then it goes straight into production? Code is changing all the time. So I think this is where it is absolutely imminent to combine the real-time awareness of customers' digital systems to understand what's going on in there, combine that in a deterministic way to know for a fact what's out there, then with the creativity of then the large language models, combine that into an agentic AI system. This is, in my opinion, the best way to get a very reliable approach to solving problems autonomously or even preventively avoiding problems to occur at all.
I think the human in the loop is really important in this context. That, you know, we've talked about the trust, the importance of trust, and understanding what proposed changes are being made to the system. And we're going to want to sort of gain that trust before we give more and more responsibility and less oversight. What if we zoom out for a minute? You're creating a system that itself is quite complicated. You know, a bunch of agents approximating the different types of workflows that an SRE does to better inform an SRE to be able to respond quickly and even extend that information all the way to developers. Is there an observability challenge with watching all the agents?
Oh yeah, absolutely. So this is really important to understand. Sort of there's the AI observability that actually is about observing other AI. What used to be cloud native is going to be cloud and AI native, because there is basically no modern new digital service that you stand up that also doesn't have some form of AI with it. And so what this means is that basically the number of microservices containers that you already have there, you will add down the additional inference service that you leverage then for the agents that you build on top of these. So, and all that comes together. And obviously, now when you think that a Kubernetes deployment, as it grows to thousands, 10,000s of containers, becomes a complex beast because everything is talking to each other. But when you now add in agentic AI, you no longer have so much control as you used to be, because now these agents talk to each other almost in a language they want. Does it do what it's supposed to? Is it doing it within the cost boundaries and performance boundaries? But then you have the other facts too. Is it compliant? Is it starting to hallucinate? Is it within the guardrails? So there's so many questions around that makes it actually mandatory to observe then this system, because otherwise you have no chance to guarantee any quality. This is why the debate is already a big one, that we all know that the capability of generative AI is fantastic, but the reliability is the key challenge. And I think this is also where this approach of observing it and also proactively stepping in when needed is a way to help customers with the reliability of their AI-enhanced digital services.
I think that's critically important. I mean, you can imagine a remedy suggested, a hallucination that says the best way to remedy this issue is essentially delete the database and start with a fresh schema. Like that would be catastrophic for all the obvious reasons. You mentioned the ability or the flexibility of including agents potentially from other systems. Technology-wise, are there key technology components that you're using, agentic frameworks, protocols that are important to create that kind of integrated solution?
So if it's about interfacing with the ecosystem, then right now is MCP, of course, a key interface sort of to integrate into IDEs, also remote MCP for integrating with the partners, including yourself, but also the agent-to-agent protocol also eventually arises, but the market is moving so fast so that in 2 months there might be another protocol. Basically, the whole point is, yes, there is the integration with the ecosystem is super important, because I think this is the whole power of agentic AI as well on this one, that this is not just an isolated tool, but actually a collaborative effort to get the best competence and expertise from different services and bring that together in a best optimal way that actually is reliable as an outcome.
Yeah, I think the open standards are key here, and of course they are evolving as fast as we can imagine. But building off of those, I think, is fundamentally important. The data collection from the system, that real-time view, sounds fundamental, critical to build the right knowledge graph. Is there anything that, insights that you have in terms of how you do the instrumentation and observability to gather the right data to build this worldview?
Yeah, so it is that, for instance, we hook up to the Kubernetes cluster with an operator that auto-discovers then all the different containers running there and instruments not only the infrastructure level, but actually instruments even into the code level, so that really the depth is understood, and this enables automatic tracing, automatic log analytics, automatic metrics gathering from the infrastructure. But also those traces are attached to end user experience, because if there are front-end tiers in there, those are instrumented as well, like mobile apps or web apps. And the end user experience is actually the most important one to tie then to the business outcome. And this is why also I keep saying that, yeah, watching CPUs is nice, but actually more important it is to understand what is the actual end user impact, because you can have a CPU go out of whack, but no user is impacted by that at all, because of the system is able to handle that. So this is why it's more important from there, and this is also why exactly building up such a graph that is real time allows to do then the impact and risk analysis also in real time to inform then the remediation step or reasoning step to drive corrective actions, whether they are remediative or preventive or for optimization reasons.
Do you look at all at observing the operations of a quote unquote intelligent application? So there's business logic encoded in one service, and there's an LLM in another service, and the relationship between the application calling into the LLM. Are you thinking about instrumentation and visibility into the generative AI piece of an application itself?
Yeah, actually, we look at all the different layers from infrastructure, sort of where it's the bare on CPU and the basic metrics, all the way to the application layer. What are those services communicating? How are they talking to each other? Sort of think of logs, traces, and metrics, and then also the end user in this. What is the end user actually getting as a result from this, or the other machines? It can be machine to machine, of course. But also then, what is the business outcome, and is the business goal achieved with this? And this is where observing AI is almost more the technical aspect, but we also have a layer that we call business observability, because we also turn the pure technical high volume data into a smaller set of what we call business events, and provide our customers an abstraction layer that is meaningful to the business people, because they don't want to know how much CPU is out of that inference engine did use. They want to know how many people actually purchased or did whatever meaningful to their business with help of this outcome. And this is exactly what we bring together by actually leveraging all that context-enriched data, bring it to a business level, and allow customers understand the full pipeline and flow.
I think that's really important. There's a lot of questions in people's minds. What is the outcome that I can produce by leveraging AI? If you forgot the question, but you know the answer is AI, we're probably dangerously into hype and buzzword land, but if you're able to demonstrate the value, I think it really helps cement in people's minds the use cases and the efficiency that can be gained.
There's for sure value. There's no way back from AI, so this is the way forward. But we have also a certain responsibility to use it in the proper way. And this is why it's important to start with smaller steps, make sure those work, and really do crawl, walk, run with AI, or bring in external products that did that already and help customers with this so that you can build on something that provides value. It is not just a huge experiment. But also on this one, I hear very interesting use cases, some where I say, yeah, this is where I believe this is what humans never could do. And this is also where AI helps. For instance, one customer wants to transcode 20 millions of mainframe code into documentation, and from documentation to Java code to clean. And this makes sense because you could not hire that many people ever to get in a reasonable time frame. So this is a use case that is still super ambitious, no guarantee that it succeeds. But I think this is one where it has a higher likelihood actually by using AI than trying to hire 2,000 developers to transcode this mainframe up. But this is the advice. Don't look for the magic one line and stuff happens. Look for, you have great structured input and make something useful with it. This is why I also believe in this transcoding use case.
I'm with you. I give similar guidance internally to our engineers, and part of it is that iterative work we've learned really well in open source, how to do small iterations continuously and really improve a system where every iterative step is providing clear improvements and value. There's a lot of enthusiasm around the potential here, and you'll hear conversations, certainly from an executive point of view within a enterprise customer base, expectations even for the amount of efficiency gains that we can generate with AI. What are you seeing in terms of creating this agentic AI system and observability to help manage and operate complex large-scale infrastructure?
Yeah, I hear frequently from executives that their expectation is that within the next few years, 70% of their entire engineering workforce gets automated, and they have huge productivity gains. I think that, yes, there is a huge potential and value in AI, but also right now we need actually more people to make that AI work and really deliver the value. And the other part is every competitor in the market will also leverage AI. Basically, you just shift the workforce's type of work from doing the actual things to more directing the AI, but you still need people to supervise what's going on. Otherwise, you can't stay competitive. So the outcomes might grow. You might get faster along the way, but I think all the people who skill up in this entire game will have more work to do than ever before. So basically, you don't need fewer people. You need people to do different things in the future. And this is, in my opinion, the big change.
Well, thank you for indulging in that question, and really appreciate, Bernd, your insights and such a long history in systems observability and extending that into agents and making that very practical and useful in a meaningful way to help us advance into this exciting future. Thank you.
Thank you very much.
It's fascinating to think that as we add more automation and AI-driven agents, the need for deeper observability doesn't just increase, it becomes absolutely fundamental to trusting the system. Bernd's point that you can't have deterministic outcomes without high-quality contextual data really hits home. Before we can hand over the keys to the kingdom, we need a shared, trustworthy view of our entire environment. It shows that the future of autonomous operations isn't just about letting go of the controls, but about building a new foundation of trust so we know exactly what the system is doing and why. Thanks to our audience for joining Technically Speaking, where we explore how open source is shaping the future of technology. I'm Chris Wright, looking forward to our next conversation.